encounter when you are performing a rocket outer space expeditions. And also, I will introduce you the board game called the High Frontier for All. So this is the cover of the game. So this is my overview. First, I will talk about how we need to consider about launching a rocket and the important idea about the delta V, which we will use in the rocket mission. And then we will briefly talk about these three concepts: the gravity loss, gravity assist, and the overse effect. And finally, the whole game about rocket science. So, in the beginning, I want to show you some interesting data about the rocket we were using, the Saturn V in the moon mission and the Falcon 9, which we are using now. Okay? Well, we're not successful yet. But so what we can see now is the full mass of the Saturn is like 2,800 tons. However, its payload to go LEO for the low Earth orbit is only about 0.14 tons. So it's like 5% to the full mass. And if you compare the dry mass, which is the rocket mass, so it's not much more. It's almost less than 10% of the full mass. So you can consider this almost 80% to 90% of the mass is in the fuel. So the rocket is basically a gigantic fuel tank. And all those fuel is used to transfer the other fuels to the space.
Very inefficient.
Yes, so this is a huge problem that we use a lot of propeller. So, okay, so we want to think about how can we escape the gravity of the Earth. So you can first think about the perspective. So it's a gravitational well of the Earth. If you want to escape, so you need to provide the potential energy of the gravity. And so by using this energy, you can also calculate escape velocity. So you provide enough velocity, which is the momentum equal to the potential energies, then you can escape. So this can provide the huge fuel consumption to escape. Right. So in practice, what we do, what we calculate is the so-called delta V. So it's nothing magical. Delta V is delta V. So it means the change of your velocity. Now, why would we want to use this number? Because when you use rocket, this is like an impulsive type of engine, which means it provides constant force, and which means constant thrust, and which means you get a constant change of your velocity. So, because your force plus time is your burn time, so we provide your change of velocity. So therefore, your fuel consumption amount is closely proportional to your total change of your velocity. So you can see this graph is the moon mission. Apollo mission. Yes, so you can see the two plots. It's the delta V and is the consumption of the fuel. And you can see it cut into different phases of the mission, and in each phases, it will calculate particular delta V, because now you now you have the idea of the delta V. So what is the gravity loss? So the principle is very simple because gravity is an acceleration. So if you plus gravity plus t is delta V, right? Which means if your rocket say you are ascending from the Earth, and the longer the time it took, the gravity will give you more delta V, and so you will waste more fuel in the path. And this extra fuel consumption is not related to your energy. You can it's not providing you any extra kinetic energy to compensate the potential energy. So you imagine the extreme cases that your rocket go vertically upward while your propulsion just cancel out your gravity. What will happen is that your rocket just stay in the air and it doesn't move. You don't leave the earth or you don't drop down. However, so the energy is the same. However, your fuel continues to burn. So it's total waste to us. You only use the energy without any boost. So this cost, the extra cost is the gravity loss. So okay. So can we get some advantages to go out of the Earth? So it's simple. If we choose the rocket closer to the equator and we shoot it on the east, so you have the velocity of the rotation on the surface of the Earth. So you get closer to the equator, you get bigger velocity, and if you fire to the east, you get bigger initial velocity on your rocket. This is one of the examples. And the point of this picture is that the JAXA is a very cute satellite. So the gravity assist, you might have heard it. This is a very important skill we use when we want to send like physical satellite to the other planet. So can you? Oh, I'm sorry, you cannot. Okay, so this is the gift, but anyway. So
Well, the animation gif, right?
yes,
Where it doesn't move?
because
Oh, because this is video. Oh, okay,
Yes,
fine. No
because
problem.
his computer
so
had
I'm-
connection problem, so he used my computer.
Okay.
So I will just hand wave you. It's a simple idea. So it's easier to understand from the race frame of the planet. So if you fire your satellite toward the planet, the crew it will be pulled by the gravity and then escape because you have non velocity. So it's like a curve. You go like this.
So the black is planet and then
Yes,
blue is your rocket, right?
yes.
Or satellite, spacecraft.
Yes, it is spacecraft. So you, by the conservation of energy or momentum, you will ensure that when you leave the planet, you have the same velocity when as you come in. Now, if you move into the solar flare in the sun, then you will see the planet is moving. So it moving in this direction, and then your spacecraft is propulsion and you come this way. So the important thing is that you
Maybe you want, you can just click that URL, then it shows animation, huh?
it's not a link, but it's just an address.
Here,
It's not a link.
this one.
Oh, thank you. Great. So you can see in the sound spread, you will see that they will go out with a boost in this expiration because its velocity of the satellite is almost practically plus by the own velocity of the planet too. So the overall effect is that your spacecraft will take the momentum from the like a slingshot. So you come along from behind and the planet will slingshot the craft with a velocity. Of course, you can go backward, so you can slow you down too. Okay, and then the overall effect, which is a little bit relevant to your previous to the previous thing. Now this overall effect is mathematically very simple too. So it's work. You know the work is force plus your distance, your moving distance. So you can see that your power is your force times your velocity, which means is that when you fire the rocket, if your rocket is at a higher speed, you get much more power. The power is proportional to your rocket speed. So when you want to explore the overall effect, when you go approaching a planet, you get much faster speed because of the gravity. And when you are coming very close to a planet, you get the high velocity and you fire the rocket to get a much more power. So it will be a more energy efficient way to use your rocket in the bottom of the gravitational wall. Okay, thank you. So now we finish with all this academics. So this is the GAN, the high frontier for all. Now this for all means because it is the fourth generation of this GAN. So this is very straightforward. The players in this game, they make a space race to explore the entire solar system. So you explore and you earn credit, you earn points to win the game. Now the starting point of this game is that it is produced by, sorry, this is an error. She's not an astronomer, she's a rocket scientist. So this game is using the real rocket science. Now, so this game is so complex that it actually contains 3 games in this one. So the first one is called the Space Diamond. This is game for kids. You can play with the kids too. And the second game is called Race for Glory. So it basically serves as a tutorial of the real game. And the third one is the High Frontier, the real game, what we are talking about. So there's no problem with all we astronomers to just go to the third one, right? Okay, so now this is the table of the frontier.
Oh.
So no problem, right? We are all astronomers. Like it too. So you can see all these lines, they are the trajectory or orbit of your spacecraft. And all these boxes are like points. So you can yes, so this is a closer look. You can see, for example, this is like the blood point. And you can have the radiation zone. And you can see all these numbers. It means that if you want to go along this path, how much delta V you need to provide by your rocket. Okay, so how do we play this game? First, you need to build your rocket. So you need to buy component pattern. So for example, you can see the starter, and like you have the generators, you have your reactors, and you have to prepare your crew. So we buy all these patterns to combine to build your rocket. And you can see that this is the text for each players. Now this one you can see these are called aquas. They serve for 2 purposes. They are the fuel of your rocket and they are also the currency of your game. You buy your rocket pattern and build this component with these aquas and you rocket burn on it too. Now you can see all these tables. And you can see first this is the induction. So if the component of your rocket will provide these numbers, so this means the fuel efficiency. It means when you burn your 1 unit of your alpha, how many thrusts it gives you, and this one is the consumption. It means when in 1 row, how many alpha you burn. So you like in the previous case, you see you have all these numbers, so all the components add up, and this number means this mark means you can take the solar energy too, so you can get the energy if you are functioning closer to the sun. And this is the back burner. It means you can get an extra thrust if you put an extra fuel in it. Okay, so go to this table. Now this bottom, this red back number is the weight. And you can see there are 2 marks. It means dry and wet. It marks, these 2 marks marks the total weight of your rocket. So dry is is all your components weight, and weight is when you add on the alpha. So example, if you have a dry, maybe you have a dry here, and you load it with your fuel, like 3, so you get 3, you get wet here, and dry here. Now in your run, you can decide to fire the rocket. So you can see, for example, if this is 1, so you can go like this one. And however, this line here, it marks your total thrust of your rocket. So like I said, you have this number here, so you add up. So example 3, so that means you have 3 delta V or 3 moves in your math. So you can things will be like you have 3 steps. And this one count on how you use your fuel. And you will notice that there are 4 graphs here, which means the weight. If you have higher weight in the total weight in your rocket, you get fewer thrust, your propulsion efficiency, which means you're harder to cool, so you burn much more fuel. So this pretty much all for this introduction of this game. So when you are interested in rocket science, I'm sure you will enjoy this. So
Really?
I'm probably not going to play soon. So thank you everybody for listening.
What's the goal of this game? How do you
Oh yes, so
finish? Yeah.
can you upload the
Which page?
yes, so you can see there are all these outposts. So the goal is to earn credit or points. So what you do is you send the rocket get out of the space, and you somehow you find like you go to the planet or go to the moon or go to explore the asteroid. So you get your reputation, and you can also use your material to build like a colony or build a foundry to earn more resources and credit. So the overall the players earn the most of the fame and resources will win again. So it's
So
like
when does it end? So, like, how many players gonna play together?
well, it's like 1 to 5. Well, you can play on yourself, but yeah,
Okay.
you like
Then
6. So,
does it finish?
well,
So 5 players. Okay, one get to moon, one get to asteroids, make a colony. Blah, blah. I mean, when does it end?
well, I think when the round is over, when each round represents 1 solar year, so there's a time limit in your game.
Okay. So after some years, they just finish and compare what is the reputation goes for.
Yes.
And
Yes.
then if you get more, you win.
Yes, so it's like a space race simulator. You want to compete. For example, you are NASA, you maybe play NASA, so you want to beat the European and the China. Oh yes, so each unit has their own special skill. For example, they can commit fairly, yes. And the Europeans, they have a better efficiency in the rocket, I think.
So can we attack each other?
I think you can if you have these modules. You have different modules, it's like an add-on or DOC. Right?
Okay.
So it's like module 0 is the politics. So you have a politics table to make your decisions and investment fundings like that. I think there's a common module so you can get on board with that.
Okay.
So it's very fun game.
Is it?
Recommend it for you, not for me. Okay, the bottom line is you use delta V, and you have like Lagrangian point, and you have entry point, you have a landing pad. Like you can use the power landing, or you can use the no power landing, like the parachute landing, and you can take risks too. You can take chances, and if you fail, throw dice, you fail, and you crash your rocket and lose everything. And there's something like that. Failure is not an option. So you invest more to overcome any obstacles too. So yes, it's like a space project simulator
Okay.
with real science.
Okay. Somehow I feel I don't want to play this. It's interesting. Okay, questions, comments, please. As usual, Yuan is counting questions, so please get more points. No questions?
How long to finish a round?
Well,
Which
it's,
do you have?
in the table is like 1 to maybe 5-6 hours.
Really?
Well, 1 hour to like 5 hours or 6 hours. You can play very long or you can play very quick. It depends on the players. Well, if you get familiar with it, it's not so hard because you have this test.
Oh.
You can calculate all these thrust and burning problems for you. So what you need to actually think about is how do you use your resource to build a more efficient rocket and earn as many reputation as you can.
Also, scientists already calculate the thrust for you, and maybe
Yes,
this is a game for politics.
Well, yes, but I doubt they will play this game.
So when I quickly checked, the manual has 276 pages.
Oh yes, because it has real explanation of all these scientific terms in this game too.
Okay.
So you can actually learn. You don't just play. If you're interested in anything.
And I think manual is more interesting.
But this is like a fourth version, right? You said. So it must be popular, no? Otherwise, they don't create a fourth version.
Yes. This thing is like 2 decades or 3 decades old for this series.
Okay.
Yeah, it's fun. I agree.
I found something different in each hexagon. Hexagon, 六角形.
Yes.
Yes. Is the meaning is the meaning different spatial mission? Different mission in each hexagon.
Oh yes. So like I said, they are basically labeled as points, like the Lagrangian points.
Lagrangian point.
The Lagrangian point, right? It's a stable position where you get neutral gravity, so you can it makes it easier to maneuver because the gravity cancels out, so you can like floating freely without any pull. So delta V is 0, like almost right. So for example, you want to choose where you want to, how you want to entry the planet, or also you can make the colonies, build your station and foundry workshop like this. So yes, so every hexagon has their own meaning too.
Alright, could you explain again, how can aqua work?
Yes, so I think it's more like your fuels stored in your station.
Oh,
So because you start at the LEO, the orbit, and this aqua is like proportion. So it's the fuel of your rocket. It's the main purpose. But however, you can use them to trade. They are also the currency. For example, if you want the pattern to build your rocket, you need an auction, which use the aqua to bid for the pattern. And if you have the pattern, you need to build the component which also uses aqua. So it's the resource, money, and to prepare your rocket.
so we cannot build the rocket unless we have aqua.
Yes, the component costs aqua.
Okay, thank you.
Okay, no more questions? Then I guess you have a quiz, right?
Yes.
Shall we go to quiz?
So this is the easy quiz.
Really?
Yeah, very easy. You don't ask the questions, so you don't get all these ideas. They're simple, right? Well, I get confused many times when I get this report, so you're all okay. The,
Yeah.
Do you remember what is delta V?
play. So
Maybe internet is slow.
Let me check my internet.
I need to reload.
So can you log in again? Okay, great.
No sound.
So everyone's in?
Nanya?
Nanachi is not here, so
Yes, Nanachi and Jody is not here.
okay.
So
Yeah.
we only have 9 people today.
So we have
Eight.
Oh, 8, yeah, 8, 8.
so it's up.
Yeah.
There's no tricky question here, so don't worry.
Questions follow closely to the plane load, full mass ratio, and
The first page when we say the efficiency of the rocket.
I
So
forgot.
I forgot too.
Which follow closely to the plane load, full mass and ratio station. Yeah,
The first page of his report.
so the
I forgot.
of the
5%. 5%
it's
of the
like
load.
14 to 280.
Oh.
It's 280, no, 2,801. So it's very, very efficient.
Only one person remembers it. Is that you?
Me.
No, I don't.
Oh, Terry, you're good. Do you remember?
Just estimate. I don't remember exact number, but
Only
just
me remember.
Okay.
How to launch a rocket with its initial speed.
So remember the Q satellite. So then this question is about where you launch your rocket and how you launch your rocket to get the most initial velocity. Remember the JAXA satellite and rocket. Okay, so if you remember, because the Earth is rotating, so if you are closer, you have the lowest latitude in the equator, so you have the maximum velocity on the surface of the Earth, and you fire eastward to fire along the rotation of the Earth.
Which is used to estimate.
Well, this is the only most important question in this talk. Okay, great.
Oh, everybody got it. Good.
Nice.
Good, now you learn something today.
Terry is doing good.
So in the third case, you remember the gift before we go this way. So it's like you approach from its left or right and you come out this way or the gift. The gift. The plane name go this way and you do it this way. The spacecraft that is one, so possibly this or this or this. Yes. So the key is to approach from behind and you will slingshot you to the front. Yes.
Everybody got it right. Good.
Yes, the gift is working, so thank you.
We can use R1
So it's well, I didn't talk about it, but
I'm not sure.
we'll just make a guess. So by your intuition. So actually we do, and we have using it for a long time. The moon coming shuttle.
Leah is doing good.
No.
I'm not Leah, it's Leah, right?
Okay.
Oh, double score.
This is more complete.
Where do we get extra kinetic
So like
when
when you use a boost to increase your velocity, where is the energy come from?
Tricky question.
planet will slow down a tiny little bit. So the kinetic energy is also transferred like momentum. It's how we get the boost in velocity or kinetic.
What's different between red option and yellow option?
Because it has the gravitational energy, it doesn't get because you come into the gravitational field of the planet and then you leave. So the total change in the potential energy is zero.
Oh.
Right. So the only energy change is the moving kinetic energy of the planet is slow down a little bit.
Oh.
This is how I call it. You store energy.
Mm.
But it's very big, so it doesn't care.
Mm.
So anyway, no dark energy. Right?
Change number one.
Oh.
Okay.
Oh.
Now this one is a similar question.
According to
So over effect. The next one I talked about the
what is the actual
boost. Okay. So you get higher. Like I said, if you boost at a higher V, you get more efficient, which means you get more energy when burning your fuel.
Mm.
Why is there more energy during the fuel? Yes, so most of you get idea. Because the total energy waste on the gas is smaller.
Oh, okay.
So you can imagine if you go faster, so the gas leaving behind will be slower. The different energy is coming to this faster along.
Oh, okay. Kelvin.
Okay, this one is a simple one for the final. So say you come in. So the question is when you leaving the planet, is the whole effect also work? It means no. So if you work, it means no, it's not working. It is working. But it's not working here. Working. Sorry. So yes, so it's not about going in or going out. This is only about your velocity of the craft itself. Okay, so
Only 1 point.
Oh, 1 point different. Oh.